Hi everyone, welcome back to my channel. Okay, today let's continue the properties of the tangent. The tangents drawn from the same external point are always equal, right? Look at here. This is a tangent drawn from the point T, that is external point. And this is another tangent which is drawn from the same external point T. Now, if both the tangents are drawn from the same external point, then here TA will be equal to TB. So remember, whenever the tangents are drawn from the same external point, then they are always equal. Okay, look at this example here. Here, you can see in the circle, TA and TB are the two different tangents, right? With a point of contact B and A respectively. Both the tangents are drawn from the same external point. An angle T is given at a 60 degree, TB is equal to 15 centimeter, and the length of AB we have to find out here, okay? Since the tangents are drawn from the same external point, we can use the property of the tangent here. Now we can say here TA is equal to TB because tangents drawn from the same external point, that is T, right? Now here, since TA is equal to TB, we can say TAB is an isosceles triangle. Okay, now we can use here angle TBA is equal to angle TAB. Why? Because from fact 1, base angles of an isosceles triangle. Okay, now we can use here angle TBA plus TAB plus angle A is equal to 180 degree. That is sum of angles in a triangle. Okay, now we can use like this way, angle TBA plus angle TBA, because we replace TAB by TBA, because here angle TBA and TAB both are equal, and plus 60 degree equals 180 degree. So here we can add these two angles and we can make it twice angle TBA is equal to 180 degree minus 60 degree. So here angle TBA is equal to 180 minus 60 gives you the 120 degree, and divided by 2 will give you the 60 degree here. Now we can say here angle TBA is equal to TAB is equal to angle A is equal to 60 degree. It means that in the triangle TAB, all angles are 60 degree, which means that we can say triangle TAB is an equilateral triangle. Okay, now in equilateral triangle, what happens? All sides are equal. Now, since TB is equal to 15 centimeter, we can even say that length of AB is also 15 centimeter. Okay, look, and this is another property here, which is very important property. Angles in alternate segments are equal. I hope that you remember what is the segment, because I already described in the previous videos. If you don't know that, you can see in the link given above to check that what is the alternate angles. Okay. Now remember, angles in alternate segments are equal. Let's look at here. This is a circle and here is the tangent where A is a point of contact, right? Now here, I draw the curve through the point of contact A. AB is a curve through the point of contact A. When I draw this curve, what happens? The angle will be formed by the curve with the tangent, right? So BAN is a angle which is formed by the curve with the tangent. Remember, this angle is always equal to the angle drawn in the alternate segment. You know that the curve divides the whole circle into the two parts. You can see the minor segment, the below one, and the upper one, that's a major segment, right? Remember, the angle formed by the curve with the tangent, that is angle BAN, must be equal to always in the alternate segment, that is angle ACB. Okay, now here, look at another figure. Here, this is a tangent TAN, the same point of contact, and here I draw the curve AC. Now here, when I draw the curve AC, what happens? The angle CAT will be formed, and this angle is always equal to the angle in the alternate segment, and that is angle ABC. Now in the first figure, you can see here, angle BAN is equal to angle C, and in the second figure, you can see here, angle CAT is equal to angle B. Okay, remember, angles in alternate segments are always equal. Okay, this is very important properties. And alternate segment doesn't mean that it's the alternate angles. It is an angle in alternate segment. We are going to use this property in the upcoming problems, right? Look at here. Okay, now here, look at this problem. Here you can see O is the center of the circle, right? And TN is a tangent with A as a point of contact. Here, AB is equal to BC, and angle BAT is given as a 50 degree. Now, we have to find out the angle CAN. Now, let's look closely. Here, we know the properties, angles in alternate segment. Okay, let's use that one. When you look at the angle BAT, it is formed by the curve BA, right? So this angle BAT will be equal to angle C. I just told you that angle in alternate segment, right? Now here I can say angle C is equal to 50 degree. Now remember, AB is equal to BC. It means it is an isosceles triangle. So we can say here angle BAC is equal to angle C, right? It is the base angles of the isosceles triangle since AB is equal to BC, right? Now here we can use here angle BAC is equal to 650 degree. Okay, now we can use here angle BAC plus B plus angle C is equal to 180 degree. In a triangle ABC, we are taking as a sum of angles in a triangle. Okay, let's keep the value here. Angle BAC is 50 degree plus angle B plus angle C also 50 degree. That gives it 180 degree, which means that angle B is equal to 180 degree minus 100 degree. Okay, so angle B is equal to 80 degree. Now we found angle B. Now let's look closely. AC is a curve, okay, and AC is a curve, and AC has made, angle with a tangent, that is angle CAN. So CAN must be equal to angle B, that is angles in alternate segment. Okay, and here that's why angle CAN is equal to 80 degree. Okay, now let's look at one more problem. Here O is the center of the circle and AQB. Okay, I've written here P, so that is B. Okay, just remember AQB is a tangent. Okay, and Q is a point of contact here. Okay, now we have to find here PRQ is given as a 35 degree, and we need to find out the angle RQB. Do you know that RQB is the angle formed by the curve with a tangent? RQ is a curve and AQB is a tangent, so angle is formed in between these two things, right? So RQB is the angle formed by the curve RQ with a tangent AQB. We have to find that angle. Okay, let's look at another figure. What I did in that figure, did you notice there? I just joined P and Q. See, as soon as I join P and Q, remember PR is the diameter, passes through the center. As soon as I join the P and Q, then what will happen? Look at here. Angle PQR will be equal to 90 degree, right? Because PR is the diameter and PR divides the whole circle into two parts. In the lower part, semicircle, PQR is formed. So that is called the angle in semicircle, right? So we made PQR is the 90 degree. Now here we can use PQR as a triangle, and we can use here angle PQR plus angle PRQ plus angle QPR is equal to 180 degree. That is sum of angles in a triangle. Let's keep the value. PQR is 90 degree plus PRQ is, we know that's given 35 degree, and angle QPR is equal to 180 degree. So here angle QPR is equal to 180 degree minus 125 degree. Okay, 90 plus 35 degree is 125 degree. Here angle QPR is equal to 55 degree. So we found angle QPR, correct? Now let's closely look at here. What is QPR? QPR is the inscribed angle, okay, which is standing on the RQR. In the same RQR, if you look closely here, you can see QSR is also standing on the same arc. So we can say here angle QPR is equal to angle QSR. Inscribe angles standing on the same arc QR. Okay, so we can say here QSR is equal to 55 degree. 55 degree. Okay, now since we found the QSR, now look at here, we can say here now RQB, that is the angle which is formed by the curved RQ, is equal to the QSR, that is angles in alternate segment, right? Once again, look at closely. RQB is equal to angle QSR because QR is a curve, and we have to find out this angle is equal to the alternate segment angle. Okay, so now we can say here RQB is equal to 55 degree, since QSR is also 55 degree.